Hello friends, last class I discussed about the multiplexer and its working principle and how many types of the multiplexers are there, and if you have the boolean expression how can you design the multiplexer, right? So how can you design the boolean expression using the multiplexer? So there is a one combination circuit, that is the demultiplexer. Demultiplexer is that is opposite to multiplexer, right? So in multiplexer what we have seen that in multiplexer if you have the multiple input channels and you have the one output channel, so that normally we used to transfer the different kinds of the input information through the communication, okay, through the communication channel. But rather sending multiple input channel, I used to send the only one input channel for multiplexer. So at the other end, in the receiver, we need the information in various ways, right? So in receiver, normally we need the demultiplexer, right? So this information is sent through the one communication channel. After that, at receiver, we have to use the demultiplexer, D marks. Okay, so when you need some particular information, that information will be transferred through the communication and that will be transferred at the particular channel, okay, output channel at the receiver side. So in multiplexer, you have the only one input and you have the multiple output channels, right? So at a time, only one information will be collected by the multiplexer and that will be transferred through the particular channel at the receiver side. Okay, so this is about the demultiplexer. If you see the, suppose you have the 4 is to 1 marks. So in case of the D marks, it will be 1 is to 4. So 4 is to 1 marks, you have the 4 input channel, 2 select lines and 1 output. So for case of the D marks, so you have the 1 input channel, 4 output and the 2 select lines. Just opposite of the multiplexer, right? So how can you write the truth table for 1 is to 4 multiplexer? So first I'll tell 1 is to 4. So if you have the 1 is to 2 demarks, so what will happen? Only one input, two output channel and one select line. Same formulas are there. So here the formulas are associated with the input, number of input lines and the number of select lines. In case of the demarks, select lines are associated with the number of output channels and the number of select lines. Okay. So in case of the 1 is to 2 demarks, right? So these are the two output channels. Okay. So we have the select line. So what will happen? So you are giving the input. So here it is output 1 and output 2, right? So what will happen here? Uh, Select line output 1, output 2. So when you select line 0, the I will get I at the output 1. Okay. When you select line 1, I will get I at the output 2, right? So if you want to write the information, right, write the expression for you. So y1 is equal to s1 prime I and o2 is equal to s into I, like this way. So when your select line is 0, so information that will be transferred into the O1 channel. Okay, when your select line is 1, the information that will transfer into the O2 channel. Okay, so in this way you have to write. So when you select line 0, I will get information I at the O1. When my select line is 1, I will get information I at the O2. Okay, so O1 is equal to S1 I and O2 is equal to S into I, right? So for same way, you can write for the 1 is to 4 demarks, right? 1 is to 4 demarks. For 1 is to 4 demarks, you have the 4 output channel, O1, O2, O3, O4. Here it is S1, S0. Okay, the same way S1, S0. O1, O2, O3, O4. Right? So if both are 0, 0, only you will get the information. I you will get here. Okay. If it is 0, 1, I will get here. If it is 1, 0, I will get here. If it is 1, 1, I will get here. So if you want to write 1 expression, what will happen here? S1 prime, S0 prime, I. If you want to write O2, it will be S1 prime, S0, I. Like this way you can write for O3 and O4. Right? So this is about the demultiplexer. Right? So only simple things are there. Only 1 is to 2, 1 is to 4. And if you want to write the 1 is to 8, you can easily write the multiplexer, a demultiplexer equation for 1 is to 8. Okay. So now come to the one more topic. This is so this thing normally all the combinational circuits I am discussing. So multiplexer and demultiplexer both are two kinds of the combinational circuits. And now come to the encoder and decoder. What is the use of the encoder and decoder? So today I'll just give you the some basic introduction of the encoder and decoder followed by the decoder. Okay, so I am drawing here encoder and decoder both, right? So encoder means which encodes something and decoder means which decodes something. Okay, so normally encoder is used in the transmitter side and decoder is used in the receiver side. Okay, so normally if you see, if you want to send the decimal number into the computer, so the computer will not understand the decimal number. We have to convert this decimal number into the binary. And again, if you come to the, if you want to read those decimal binary number, for our purpose we need the decimal number. We cannot read the binary number. Okay, when we want to retrieve the numbers from the computers, right? So encoder means it which converts the readable number to the coded number, and decoder means which converts the coded number to the readable number, right? So if you want to convert the any kind of the number system, so decimal to, mainly basic thing is decimal to binary. Okay, encoder. Encoder is the decimal to binary, and decoder is the again binary to decimal. Here I have included 4 is 4, 2 to encoder and 2 to 4 decoder. So you have the 8 to 3 encoder and 2 to 8 decoder like this way. So 4 to 4 and 2 4, this is the basic decoder and encoder. Okay, so normally what will happen here, if you want to send the decimal number, so you know, so how can you convert the decimal to binary number? By using the formula, so you can convert the decimal to binary number. But when you come to the computer will not convert this thing. For our purpose, we are converting, we are following some rules, and the decimal number will be converted into the binary number. Again, you can convert by using the other formula, you can convert the binary number to the decimal number, right? So but computer will not understand this thing, right? Computer have some computer, all the computers have some logic gates. Okay, based on the logic gates, it will follow, it will give some output based on the some inputs, right? So here the decimal to binary. So by using the encoder, the decimal number, any kind of, suppose 0, 1, 2, 3, 4, 5, like this, all the decimal numbers can be converted into the binary. Okay, and again, so if one again those decimal number which will be the readable decimal number, so again by using the decoder, the computer will convert the binary to decimal number. Again, so if you want to convert the octal to binary and hexadecimal to binary, by using the encoder, you can convert those number to the binary number mainly. Okay, for here also binary to other number. Here it is other number system to binary by using the encoder, using decoder, binary to other number systems, right? Now come to the decoder. Okay, so suppose here I am to send the 0. Okay, so if I send the 0, the 0 number will send through this channel, and using the encoder, the 0 will be converted into the 0 0, and this 0 0 again it will transfer into the here, and output of the decoder I will get the 0 here. Okay, suppose if I want to send 1, so for sending 1 I will send the 1 through this channel. Okay, only second channel. So when we send, when encoder, and that time encoder will understand that, so I am getting the logic decimal number 1, so I have to convert it into the 0 1. So it will send the 0 1 through the this channel. So output of the encoder will be 0 1. When we will get the 1, when we send the 1, output of the decoder will be 0 1. Okay, so that 0 1 that will be transferred, and output of the decoder will be again 1. Okay, for 1 I will get 1 here. So how can you send? Suppose here I am doing, suppose if you want to send 0, so when you want to send the 0, so I cannot 0 through these 4 channels, right? So for sending 0, what will be the input for encoder, right? So if you want to get a 0, so if you want to send the 0, so I will send logic 1 through the first channel. I will send logic 1 through the first channel. Okay, so that time encoder will understand, okay, so if my logic 1 is the first channel, that means so I have to convert the 0 into the 0 0. Okay, so that time we will get the 0 0 output from the encoder. So this will done based on some logic circuits, right? If you want to send the 0, if you want to convert 0 into the binary, so for that, so this is numbering as a I0, I1, I2, I3. Okay, that means the first channel I have to send the logic 1. If once we send the logic 1 through the first channel, it will convert into the 0 1. Again when it come to the decoder, that 0 0, okay, 0 0 is coming into the decoder. That time the decoder will understand that so I have to convert 0 0 into the 0 decimal number. So for 0 decimal number, decoder will send the logic 1 through the first channel. Okay, logic 1 to the, this will be suppose O1, O2, O3, O4. So logic 1 through the first channel. That means from, if the logic 1 is coming from the 1, that means this information is the 0 information, 0 decimal number. Okay, like this way. So I will discuss first about the 2 to 4 decoder. Okay, so here what is the relationship in encoder? In decoder it is if n number of input, okay, in decoder, and 2n number of output in encoder, okay, 2n number of input and the n number of outputs, okay, opposite to each other. There is no select line, there is an enable line. When I give the logic 0 through the enable line, decoder or encoder will activate. When I will send the logic 1 through the decoder or encoder, so that means an encoder will not activate, it will be deactivated. Okay, so there is one encoder line, sorry, enable line, but there is no concept of the select line. Okay, so now I am coming to the, so here in case of the encoder, if for 2 into 2 to 4 decoder, okay, so your input is n is 2, what will be the output? 2 to the power 2, that is 4 number of outputs, right? So now I am writing the 2 to the power 2 to 4 decoder. Okay, so two input I1 and I0. I'm writing first I0, I1, and here output will be O1, O2, O3. It will write like this way: O0, O1, O2, O3. Okay, O0, O1, O2, O3. Okay, so if I send the 0 0 here, okay, to the decoder, 0 0 means I have to send the logic one through the O0 channel. Okay, here it will be 0 0, other will be 0 0 0. Okay, now if I want to send that, so decoder means binary to decimal number. Now if I want to send 0 1, 0 1 is a binary number. What will be the decimal number for 0 1? 1. Okay, that means I have to send the logic 1 through the 1 channel. Okay, other will be 0. Like this way you have to do. For 1 0, O2 will be 1. For 1 1, O3 will be 1. That means whatever binary information I am sending. Okay, so I know the 1 1 means 3. Okay, so I have to send the logic 1 through the O3, and other output channel will be 0 0 0. Right? So now I am writing the expression. So here is the enable line. So for all cases, my enable line is 1. Okay, so if I want to write O1, O0, okay, so E, because E is 1 here, this is I0 prime, I1 prime, okay, O1. 1 is again E, I0 prime, I1, O2. O2 is E, I0 in I1 prime, O3. O3 is again E, I0 and I1. Right? So now if we send the logic 0 through the enable line, whatever input informations are there, I don't worry about this thing. If I am sending logic 0 through the E, so all the O2, O0, O1, O3, O, I'll get the logic 0 output from all the output channels. That means the decoder is not activated. Right? So that is the concept of the enable line. I give enable line like this way. So now inside the decoder, you have the logic gates, right? So from this O1, O2, O3, from this logical expression you can draw the logic gate. So I am drawing for only one E. Okay, I0, I1. First is the for getting O1. Let me put E here. E I am putting here. Okay, this is my O1. Now this is my O0. Okay, now O1. O1 means I0 prime, I1 prime, and E. This is your O1. O2 is I0, I1 prime, and E. So in this you can write for O3. So this all the components, NOT gates and AND gates, these are under the decoder. Okay. So if these logic gates are there, so then you will get the, if you give the 00 or input here, you will get the logic 1 at O1. That means you are getting the 0 decimal number from the decoder, right? Now come to the higher order decoder. Okay, 328 decoder. Okay, so that means in decoder you have the 3 input numbers. How many outputs? That means n is equal to 3 to the power n. That means 2 to the power 3, that is 8. 8 number of outputs. Okay, O0 to O7. Here it is I0, I1, I2. Okay, 3 to 8. So here I am writing I0, I1, I2, O2, O1, O3, O4, O5, O6. I0, I1, I2, O1, O0, O1, O2, O3, O4, O5, O6, O7. Okay. So I am sending enable answer also there. When I am sending 0, 0, 0, that means this will be 1, all other should be 0, 0. 0, 0, 1, this one like this way. Okay. 0, 1, 1 means it is 3. So under Q3 it will be 0, 0, 0. Like this way. So like this way you have to do. So 7 is normal 1 1 1, फिर O 7 will be 1 1 1. Okay, this is the truth table for 3 to 8. So if you want to draw the circuit for 3 to 8 decoder, it is be a little bit difficult. So one is so that it will be difficult. You have to write the expression for O0 to O7. So better if I design the 3 to 8 decoder by using the 2 to, if you know the 2 to 4 decoder, by using the 2 to 4 decoder, you can design the 3 to 8 decoder. Rather using the basic gates, I will use the 2 to 4 decoder. How can you design the 3 to 8 decoder using the 2 to 4 decoder? Okay, you know that into 3 to 8 decoder, how many input lines are there? 3 number of input lines are there and 8 number of output lines are there. Okay, so now here in case of the 3 to 8, okay, so 8 is the number of outputs and 4 is the number of outputs for 4 is to 8. So in case of the 3 to 8 decoder, you have the 8 number of outputs. In case of the 2 to 4 decoder, you have the 4 number of outputs, right? So you want to get the 8 number of outputs from the 4 number of outputs, right? So how can you understand that? So how many 2 to 4 decoders are required from the 3 to 8 decoder? Okay, so I will divide this output to this 8 by, so if I divide 8 by 4, I am getting 2. Again, 2 cannot divided by 4. Okay, it is not divisible. So if I divide the 8 by 4, you will get in 2. That means two number of 2 to 4 decoders are required for designing 3 to 8 decoder. So again I am telling, so for 3 to 8 decoder, how many number of outputs are there? 8 number of outputs are there. And in case of the 2 to 4 decoder, you have the 4 number of outputs. For 4 number of outputs, you need the 8 number of outputs. How can you design? So for that, your basic gate is 2 to 4. This is the child gate. Parent gate is 3 to 8, right? So you need the 3 to 8. So you will divide the 8 by 4. Total number of output. The destination number of output, that should be divided by source number of output. So 8 by 4. So that is 2. Okay. So 2, you cannot divide the 2 by 4. So it is not divisible, right? So only the 2 number of 2 to 4 decoders are required. So first I am putting 2 number of 2 to 4 decoder. 2 to 4, 2 to 4. Okay. Here I am also getting 4 number of outputs. Here also I am getting 4 number of outputs. So that is O02, O3, it is O42, O7. Okay, right? So now what will happen here? In 3 to 8 decoder, you can see 3 number of input channel. But you can see, so here it is 2 number of input channel, here it is 2 number of input channel. So how we will do this thing? Okay, so here what will happen? So I will connect the one more input channel. Okay, there I will put the one inverter and that will directly connect. That means ultimately you are getting the 3 number of inputs into the 2 to 4 decoder. Okay, so this is the enable line. So this is the enable line. This is also enable line. But if you see this one, this will be your I0. Okay, and this is the I1, I2. Here also it is I1 and I2. Okay, that means when if we see the first channel, if you want to select the O2 to O3 or O0 to O3, right? So that means this first 4 will be followed. If your I0 is 0 0 and I1 I2 0 0 0 1 1 0 1 1. Okay, so that means you are getting O1 O0 1 O2 O3. That means if I say I0 is 1, I0 is 1 means enable line is 0. Here it is 0. So for 0 0 0, for 0 1 1 0 0 1, for 0 1 0, for 0 1 1, you are getting this channel, right? So at the same time, when your I0 is sending 1, 1 means here it is getting 1. Okay, right? So when you are sending 1 here, then this will be selected. Okay, so in this way it will be happen. Again I am repeating, when I am sending the I0 is 0. Okay, I0 is 0, that means this enable line is 1. Okay, when this enable line is in, whatever 4 information 0 0 0 1 1 0 1 1 information you are sending, so in this way O0 to O3 output you will get. Okay, now if we send the I0 as a 1, okay, if we send the I0 as a 1, this will be disable. Okay, this will not work. Okay, I0 is 1, that means this will work. So from this 2 to 4 decoder, so if we send the 0 0 0 1 1 0 1 1, last 4 line will be selected. O4 to O7, this 4 line will be selected. In this way, you can design the 3 to 8 decoder into the 2 to 4 decoder. Okay. So now last topic from the 3 to 8 decoder, I want to show you the one more example from the last topic. Okay, so you have the some expression. Okay, how can you design those expression rather using the basic gate? How can you design using the 3 to 8 decoder? So you have one min terms. Okay, and writing two min terms, two functions are there. Those functions include some min terms. Okay, so you f1 is equal to summation m 0 4 6. Okay, f2 is equal to summation m 2 3 5. Okay, so you have two functions. In one function you have those midterms 0 4 6, and other function you have 2 3 5. Okay, how can you rather using the basic gates? You have to use the 3 into 8 decoder. Okay, so first I am drawing the 3 into 8 decoder. So in this expression, okay, a b c, both expression 3 variables are there, right? A b c. Okay, so in 3 variables means I used to put the 3 input lines. Okay, so you will have the in decoder 3 to 8 decoder, you will have the 4 output lines. Okay, O0, O1, O2, O3, O4, O5, want to recall the truth table of 3 to 8 decoder, so your O1, okay, your O0 is the when you are sending the 3 0 0 0, your O0 will be 1. Okay, what will be the O0? O0 will be A prime, B prime, C prime. O1 will be A prime, B prime, C. O2 will be A prime, O2 will be 1 0 0 0 1 1, A prime, B C prime. Okay, O3 will be A prime, B C. Like this way you will have the function. Suppose O4 will be A B prime, C prime. O5 will be A B prime, C. O6 will be A B C prime. O7 will be A B C. Okay, if you recall the truth table for 3 to 8 decoder, right? So here now from the midterm, so here you can see f1 is equal to within summation m046. So from this thing, what can you understand? Your f1 includes m0, m4, m6. Okay, so if you want to write in expression, what will happen? M0 means A prime, B prime, C prime, plus m4 means 4, A B prime, C prime, m6 means 6. Okay, A B C prime. Okay, that means the f1 is summation of these mean terms, right? F1 is summation, so from this thing. So that means from encoder, how we'll get this expression? Okay, if we take, so if we take here O0 and this one O4 and the O7, sorry, O6. Okay, so then I will get the f1. Okay, from this output I know the output expressions are this one. Okay, and how will get this expression from this output? If I take the output from O0, O4 and O6, so O0, O4 and O6, I will get the f1. Okay, now for f2, f2 is m2, m3, m5. Okay, m2 means A B prime, C. Okay, A B prime, sorry, means 1 0 1 0. Okay, A B C prime, plus M3 means A prime B C, and 5 means A B prime C. Okay, so how will get those expression from this output of decoder? Okay, so if I take O2 and O4 and the O5. Okay, so O2. Okay, so this is O6, O2, then O3 and O5. So by adding this thing I will get the F2. Okay, so that means if you have the any mean terms and the variables are given, so F1 inclusive 3 variables, then you have to use the 3 to 8 decoder, and from the output from the decoder you will get the F1 and F2. Suppose if we have the 4:10 decoder, so if the 4 variable expressions are given, so in this way how you can design the Boolean expression using the 3 to 8 decoder, the 2 to 4 decoder. If 2 variables functions are there, you have to use the 2 to 4 decoder, right? If 4 variables are there, you have to use the 4:16 decoder. Right? So next class I will discuss about the 4:10 decoder and the 4:16 decoder, followed by some concept of the encoder. Thank you.